So good afternoon, everyone. Everybody, thank you to SECPHO to organize this event. My presentation is about the liquid handling for in vitro diagnostics. So it's more related with the speeches we had this morning, the detection of the virus in blood and so on. I will start with the motivation. What is the motivation of this presentation? I will explain a little bit about our company, the PI Group, and then I will give a very short introduction of piezo technology, and finally I will present two applications of the piezo ceramics in the in vitro diagnostic. Sorry, I have a problem. Don't.
Can I help you?
Okay, now, sorry. So motivation due to the COVID-19 crisis, we saw an enormous increase in the global of testing devices. Especially, it was in high demand for mobile test equipment because it makes easier to be available to all the population. This so-called these devices must be very compact, work very fast, and of course the results have to be reliable. Piezoelectrical components are used in different devices of this area. They are used in genome sequencing and molecular diagnostics, in cytometry and point of care and lab on the chip systems. But first, I want to talk a little bit about the PI Group. PI is a privately owned company with 50 years of history. The headquarters is in Karlsruhe in Germany. We have a turnover of around 200 million euros a year, and the worldwide employees are about 1,300. Here we see the distribution of the different parts of the group in the world. We have 9 production sites, 4 of it in Germany, and also PI Ceramic, who was the part of the group who produced this piezoelectric components. And all over the world, we have 15 subsidiaries, and what is very important for clients, 4 service hubs in 3 continents. So after this small introduction to the company, we will have a look on the piezo technology. Piezoelectric active materials have in the basic cell and small electrical dipole. When an electrical field is applied to this material, these dipoles are orientated in one way, in one direction, and have then special properties. Then direct piezoelectrical effect is when we apply forces to this material, then a charge is produced in the electrodes. On the other hand, the inverse piezoelectrical effect is when we apply an electrical field or tension to the material. Then we see a change in the dimension of the material. Depending on the shape of this material, the polarization which has to be done, and also the electrodes, different displacements or movement can be achieved. You can achieve a change in the longitude of a block. It can make a shear movement. and also if we have a ring or tube, the diameter can change. Finally, we can also make a small curvature when we have some piezoelectrical plates. So this movement we use now for the liquid handling in small devices. So in which fields we can use these components for this liquid handling? Perhaps the most important application is the dosing, the precise dosing. Another is a droplet generation. Very important is also mixing tasks. The sample preparation and even sorting of some molecules is possible with piezoelectric materials. But why piezoelectric materials are ideal for this task in small devices? They are extremely fast. It's important. They can be produced very compact, very small, as we see here in the photo. The displacement is very precise, so we have a very high repeatability in all the processes we are doing. It has a low energy consumption and a long lifetime. So we come to the first application, and this is the droplet generation. The droplet generation perhaps is the most frequently used application in this field. When we have a volume with a liquid and a nozzle, and the piezo which is around this volume makes a vibration or changes the pressure inside the volume, a small droplet is produced in the nozzle of the device. There are several designs possible. Typically for this application, plates are used, piezo stacks, and also tubes. Here we see the quickness of this technology with such a device. 3,000 droplets per second can be produced, each with some nanoliters of volume. Another application is mixing. When we have these small devices, as we have seen this morning in some presentation, a lot of time two liquids has to be mixed, and then as it is very small capillaries, normally the two liquids to be mixed have a laminar flow, so they don't mixing. But with ultrasonic waves produced by a piezoelectrical component, we can produce turbulences inside this small tube. And with these turbulences, of course, the mixing can be performed. For these applications, also a lot of different shapes are used, plates, tubes, and rings. Okay, the last slide already. I will explain a little bit the competences of PI. So the main competence is really the production of the piezo component itself. So the material, polarized, and the electrodes. And this can do under completely customized. But in some cases, when also other tasks can be done, soldering of wires or gluing to base, until having the complete transducer. But in this case, the design has to come from the client. So when the client makes the design of the transducer, PI can also offer some additional tasks. A lot of experience we have in the production of small piezo components, very small components, which are important for the small devices in the point of care devices. From the quantities, we are very flexible. We can use prototypes, very small series, up to serial production of about 100 mil units a year. The piezo components can also be produced for clean room applications. And our most important feature is the high quality. So during all the process, the mixing process, everything is controlled. That the parameters have a high variance. So normally, when piezo components are bought from really big mass producer, there's a big variance of the final the characteristic of the piezo material or component. So resonance frequency and dimensions vary. And for this application, we need really high quality that the device is doing all the time the correct task. Okay, this is all. Here are my contact data. You can ask now or write me an email. I will be happy to answer your questions. Thank you very much for your attention.